Welcome to my final demo. Here we have a little bit unconventional, I think, use, especially of the skybox. Whereas I'm not really using the skybox as a faraway thing. I'm more so using it as, it's more close up, but you're still restricted within it. I only did that because I wanted this girl in it, and I thought it would be like weird. I would have to make a skybox of office and then like a fish tank within the office. And so this just seemed like the better route to go. Um but I do think it's a little unconventional, um and a little, um I don't know. I don't think it presents itself as well as it would in other, as like done correctly. But anyway, so here we have my Finding Nemo scene. We have our skybox, we have our volcano, that's a textured light. We have 3-point lights on the volcano. We have one on this side, one on this side. That's the falling lava. And then we have one that's just the tip of the lava. And then we have color light spheres coming out as like the air bubbles. And then here we have another texture light fish, finding that's Nemo. And then we have a color, not color light, just regular color, starfish that's in the movie. And then the texture, we have some fog. So if we move away, obviously we're not moving that far away, but I want it to have that, like, I didn't want to have too much fog, but just a little bit to have that kind of watery effect. So if we move closer, you see, we can see the fish better, and especially like right at this angle, you can see the fog really affecting it. So that's the scene. Moving on to the pre-made models. Um, model tools. So we obviously have the what's the bare minimum, which is the unit box, and then the, well, skybox is its own class, but the pyramid and the sphere. So we saw the sphere, but the pyramid here is made. I feel like I'm repeating this because we did in previous assignments, but um, basically what we're doing here is we're setting the vertices and then having the correct winding, and then we calculate the normals. So we do that for every side except the top because there's no top. And the unit box is very simple. These are, I did change the sphere, for example. I changed the scale of it in here so that I would have it at the appropriate scale. It's not technically, since these are like unit sized, I shouldn't be doing that, but that's what I did. So then after that, we have the flat plane class, which just creates a plane based off of the size that you give it. So it's pretty simple. And then we have a skybox class as well. So the skybox class takes the size that you want it to be, and then it just creates a cube of that size with the winding kind of flipping the vertex, making the square like inside out. So it does that here. My UVs are specific to my skybox, but they work pretty much with any skybox that's in that format. And finally, the model terrain or terrain model. This will take a height map, the length or the size that you want the map to be. It is a square, so it'll be size, like length times width will be the same. And then the max height that you want it to be. And then, so here we're reading the height map. And then what we do, in addition to setting the vertices and the triangles or the winding, we also set the normals here. So these calculations here are just getting the normals so that the light will hit the terrain correctly. I think that's it for the pre-made models, but for the model class, um, you have the option to give it a to create a model yourself, like we did in the skybox and terrain class, where we calculated the the vertices and the triangles, and then pass in the lists or the arrays, and then you also have the option to give it a file in which it will get the vertice information from the file, and then you can also use the pre-made models to just get like a unit shape. Um, One thing I did add um, to the model, sorry, not to the model, to the file constructor is a scale, so that basically what I'm doing is I'm just I take a vector scale, so XYZ, and then while we're setting our our vertices, we I just multiply by the scale. I multiply x by the x, y by the y, and z by the z. So you can scale it in whatever way you want while you're setting up the model, so that it won't mess with the lighting later on. But um, oh, in addition to the model class, this is the updated model. So this is the updated model class that has meshes. So you have the regular render, and then you also have render mesh, which gets once you like set the model, you'll see here you or you load to GPU, I believe. You go to the mesh separator and you get the number of meshes. And so based off of that number, when you call render mesh, we will render the different meshes that are included in that model. Obviously, you can still call render mesh even though you have one mesh. It'll just render like normal at that point. So um, we went over the skybox class. We went over the terrain model class, and then the shader class is next. So we have a bunch of shader classes. The color, I believe, was given to us, so I'll just quickly scroll through that, but this is um, pretty simple. We're just given a color and a world, and that's what we have to maintain. If we go into our HLSL files, you'll see that we have color selected. Oops. And then we have the appropriate buffers to store the world in color. Moving on to like color light, here it's a bit more complicated because you do need to set the different lights. And here, whoops, no. You'll see that um, we also have the fog data. So not only are we taking care of the light parameters, we also have the fog. So if you go into the actual class, we are creating the buffers there, releasing what we need to. And then we have just the basic set cam matrices, set directional light, set point light, set spotlight. And then you send the light parameters, set world and material. When you send fog data, if you see when we send fog data, you don't have to include any parameters. And if you don't, you just won't have fog. So it's that pretty simple, but you do need to call the function. So Um, Shader texture is also pretty simple, like shader color. We don't have the whole mess of, lights and fog. So this is pretty simple. I'll just quickly scroll through it and we'll move on to the more complicated um, shader, which is shader texture light. So shader texture light does a whole lot. So we're taking care of the light, fog, and textures. So if you see it, we have the light data, we'll have the light arrays so that we can create different lights, or not different lights, but we can create multiple lights. So in my scene, I had 3 spotlights, which allowed me to do that. And that, when we go into the HLSL file, we need to make sure that we are in our light parameters creating that array here as well, or else it will not work. And then obviously we have our fog data in our HLSL as well. And then we compute that here, but you gave that to us. Um, so in addition here, you'll see that when we set the point light parameters and the spotlight parameters, you have to pass in the indice in which you're talking about. If you don't pass in an indice, it'll default to 0. So you don't have to pay, if you just want one light, you don't have to pay attention to anything else. But if you do, then you can just pass in an indice and you can tell it which light you want to change and set parameters for. So obviously when we send light parameters, we send all the light parameters that we have in our arrays. And then when we get yeah, so the rest of this is pretty similar to color light. So yeah, like I said, the user might not want to have fog, and so they don't have to. They just need to call the function, and then they won't have any fog. So, and similar to multiple lights, they don't have to have multiple lights. It's just an option if they do, and they don't have to do anything different if they don't want to have them. So, I believe that's it for the shader class. Next up is texture. Did I go over texture? I guess there's not much to the texture. It's just pretty simple. So let's not go over it, but let's go over graphic objects. I'm trying to follow the list. But so graphic color, again, this one I believe you gave to us, so I'm just going to scroll through quickly. This is what I based my work off of. So you see that we do have meshes included in here. So just in case you need to color things is different meshes. So color light is a bit more interesting. Here, basically, graphic objects just has control over, not necessarily control, but they're able to pass information to the model, to the shader more importantly, and they're able to hold models and textures to set the appropriate things to context during render time. So it makes it very easy for the user. They literally just need one object and they can just change everything. They don't need to set each individual shader setting, which we'll see later on in the DX app. But here you see that we have vector pointers pointing to the different meshes that we may have. So if you go into the CPP file, we'll get our mesh count and we'll create our arrays based off of our mesh count. And then we'll just set them to default values. Well, of course, when we're destructing, we need to delete those as arrays. So here it'll look very similar to the shader files. Where we have the set light, set cam matrices, set to context, and we're just calling P shader. So it's kind of just a pass through, but it lets us, just have one object to control these things. When we set world, it's very convenient during render time because, comparing this to previous assignments, when we had to render, we had to set a bajillion things to context, and now it's pretty straightforward, and you don't have to deal with a lot of the extra stuff. Um, so we're taking care of meshes in here as well, and then setting the appropriate material values to the according mesh. And then during render time, we use render mesh as we saw earlier. Again, if we don't have multiple meshes, this will just render as normal. So in graphic object texture, this one's a little more simple, except you have a basically like a pointer of pointers of mesh textures, and so you have to keep track of the textures that we are holding for the different meshes. So it's just a list of a pointer to a list of pointers, I guess I should say. I don't know what the best way to say that is, but anyway. Um, so it's similar to the other one. When we set texture, we're setting it to the meshes. When we set texture without a mesh number, you're defaulting all the meshes to that one texture. When you set texture with a mesh number, you obviously set that mesh number, that mesh texture slot to the specific texture. So that's how you texture different meshes with different textures. When we render, again, it's very similar to the other one where we'll render like normal if we don't have different meshes, but if we do, then we will set the according texture as to context, and then we will render that mesh. Graphic object texture light is the most complicated of the previous. So in this, it's complicated, but it's basically just a combination of everything that we did except for color. So we have the arrays of the different meshes for the lights information, and then we have the array of texture pointers. So here, the functions are literally just a combination of everything. When we initialize it, we are we're creating, lists for our textures and our lights, and then we're initializing those. Here you'll see that we have set texture again, and then set texture with a mesh number. Similarly, we have that with set material. And then we have set fog data, which again, even in the graphic object, I don't believe I mentioned this, but even in the graphic object, you don't have to pass any parameters. I actually think that maybe in the graphic objects, I can kind of make it so that if we don't call if we don't call the set the fog function, then we can just set it to default numbers, but I hadn't thought about that before. But again, this looks very similar to the other ones, just a combination. We're setting the appropriate texture to context, and then we're setting the material and the world, and then we're just rendering that mesh. So, um, next up is the mirror. I did make a mirror class, even though I didn't use the mirror in my demo, which is I really wanted to, but time constraints was I had to take it off of I had to sacrifice it, so that's sad. But we do have a mirror class, which was exciting to automate and get all of that junk out of DX app because that was ugly. So basically here you create the mirror by just passing in a plain model and then passing in the mirror matrix. And then we're setting, basically just copy and pasted the ordering of the what was in the DX app. So here we just set all the information. I believe this is step one and I believe this is step one. Or initial setup and step one. And then when we render, so obviously we have to render whatever is, I call it like render front. So like whatever is in front of the mirror. I'm I'm blanking on whether that's right or wrong. But um, anyway, this is step two. So you render step two and then the beginning of step three, and then you render everything that needs to be in between in that. And then finally, when you render in between, that's what's behind the mirror. So if we go into yeah, that's what's behind the mirror. So my DX app, for instance, like I rendered my skybox before, I rendered my objects before, and then you render the reflection. So when I mean like behind the mirror, I mean you render like the fake objects that's behind the mirror, the reflection. So um, I do have a separate function because that was ugly. But what you basically do is, if I can find it, here, render reflection, is you take um, all the objects you want rendered in the mirror, so all the objects you want to reflect, and you basically just multiply them by the reflection matrix that's calculated in step two. So um, so then, or sorry, not in step two, in the initialization. But finally, this is the end. We render, you know, everything else. And then, oh, I do have the option to use different shaders. So obviously, if we need to render something with shader color light, we can do that. And then we have shader texture light as well. And then shader color was just the default that what we used in the beginning. But ultimately, I used shader texture light. Well, I guess I didn't use it because I didn't put it in my thingy. But that's it for the mirror class. Let's go ahead and move on to the DX app. So in the DX app, we have a bunch of objects that we create, but the header is pretty clean in the sense that it doesn't look so cluttered. Like you have a bunch of variables, but they're pretty organized in that sense. And then when we go to here, you have like, this is our init demo, which is very clean in my opinion. And what you're really doing here is loading your resources. So you're loading your shaders, you're creating your shaders, you're creating your models, you're creating your textures, and then after these, you're using those to create your graphic objects, and then you're creating the world. So here, in set shader, obviously we're just creating the 4 different shaders that we're going to use. I do believe that I use all 4 of them. If I wasn't using one of them, then obviously I wouldn't have to create it. When I create my models, I create all the different models that I am using. This includes, loading models that from a file, loading a pre-made model, and then loading a model like of a different class, so the terrain model and the skybox. When we create our textures, again, it's just creating new textures based off of the TGA files that we have in our folder. And then we use those, we use the ladder to create our graphic objects. So we just pass in the texture, pass in the model, and then set the texture or material based off of what texture or shader that we're using. When we create worlds, we're basically just setting the matrices for all the worlds. In some of these I have, for instance, oh no, I believe all of these I name. So terrain, for instance, I have as a default my world 1 because it's pretty much just centered. So if anything else needed to be just centered, I would use that as well. But everything else has its own world. Here, I set, for instance, if I'm setting the world here and I don't want to, it's never going to change, then we just set it here and we don't put it in the render function because we don't need to. After that, we are creating our lights, I believe. Well, we create the mirror, but then we set the camera and then we create our lights. So here we create all the text. I don't know if this is necessary, and I don't believe it is, I think. But because, so for instance, the terrain is a texture light shader. And if I set the light parameters for that shader, then another object that uses the same shader, because it's a pointer, right, to that shader, will not be need we don't need to set that up. Now, I didn't do any testing, but as I was implementing this, I was like, is this really needed? And I just kind of did it. And I did find in the fog, because you would assume the same thing for the fog, but I did find in the fog that it did matter whether you set it for each graphics object. So, um, but that's just something anyway. We set our directional lights, and then we set our point lights, and we do the same thing for the color light objects. This is the spotlight that's static for our volcano, and then in our rendering class, this is the render reflection that we saw earlier. So basically, you're just multiplying the reflection matrix, but we're not using that. Oh, in our update scene, we're updating worlds. So this is, I don't know if the update scene got cleaned up too much, but for a long time it's been just movements, like camera controls. But here we have, updating in the bubbles, for instance. We're updating those. Obviously, we only have two graphic objects, and then once they reach, I'm not recreating them or whatnot. I'm just, once they reach a certain height, they will be moved back down to the bottom. And then that's the same thing with the light. Once the light reaches the bottom of the volcano, it'll go back to the top. So nothing special. In draw scene, we have our skybox to render first, and then we're rendering all of our graphic objects. So here, it's pretty. This could honestly be cleaned up even more because you see we're doing the same things over and over again in render. So we could probably add a few of these into render, like setting, like not set to context, but like the cam matrices, we could probably combine with something. The world, we can pass in the cam matrices in the world in one function instead of two, and the light parameters as well. But um, by doing it this way, we give the user more ability to change what they want. But I think for camera matrices, at least, that could be, automated a bit more. But here, you'll see that if I don't include the fog data for the terrain, for instance, or oops, that's the bubble. The terrain. Everything will work just fine. There'll be nothing wrong with that. We just won't have fog for. Now this is a little bit of a test because it's like, will we not have fog for all of the texture lights? Or yeah, it kind of looks like we don't have fog for the texture light. So although we do, because we do have fog on that fish in the volcano, so that's interesting. But anyway, that works just fine even if we take that out. Again, so the draw scene is so much cleaner. You're literally just dealing with graphic objects here. You're not dealing with pretty much anything else unless you want to implement a mirror. Then you're dealing with the mirror object, which is its own class. It's still very clean. Nothing compared to what we had in the beginning of the class where I just didn't know what was going on. So here, obviously, we're just deleting everything. Other than that, I think I've reached the end of the list. Yeah, so I think that's it. Thank you.